Okay, so what we're going to talk about today is sampling methods. And there's four main sampling methods that we typically talk about in a statistics course. I mean, there are variations on these. You can combine them in like an unlimited number of different ways with the goal in mind that we want to obtain a representative sample. But there are these four major strategies that come up on a regular basis. And we're going to talk about simple random sampling in particular and systematic sampling. These are tools that are built into Excel via the data analysis tool pack. We're going to talk about how to do those. And then given those as sort of the basis for our sampling procedures, then we can build from them to build stratified and cluster sampling. Now, simple random sampling, the idea here is that essentially everybody in the data set has, in the sampling frame that you're choosing your sample from, has an equally likely chance of being selected. And then you essentially apply uniform distribution to select people from the sample until you have the sample size that you require. But the key thing is that everybody has an equal chance of getting selected. Now, in systematic sampling, the procedure is that you calculate this essentially a step size, the systematicity part of it, by determining your sample size relative to your overall population. So let's say you want a sample size of 10, but you have a population of 100. Then what you do is you need a step size of 10, and then you randomly select your first sample, your first value, and then you systematically choose every 10th person because they're 10 steps apart. 10, your total sample size of 10 is 1/10 of 100, which is your total population. And so you systematically select every 10th person after randomly choosing the first one. So that's the general procedure. Depending on how big your sample is and how big your population is, that step size can vary, but that's the general process. Now, simple random sampling is often considered the ideal in most circumstances, particularly if you don't have subgroups of the population that are very small and might have a hard time getting selected regularly. But that's sort of the baseline that most people strive for. Systematic sampling is often a procedure that is used in situations where you don't actually have everybody available at the same time, particularly in circumstances where you have lines. Then in order to randomize the people in the line, you would then pick people up systematically because they're essentially on the theory that they're getting into the line randomly. But you don't want to like pick 20 people out like all together and then have everybody else delayed while you do those 20 people. So you spread it out by doing systematic sampling. Now, the other two methods, stratified sampling and cluster sampling, are often confused with each other by students, but we can use simple random sampling, the procedures in Excel, in order to obtain our stratified and cluster sampling after we do a little bit of housekeeping. So in stratified sampling, typically you first break down the data set into strata, or essentially large groups, a small number of large groups typically. Gender is very common, race, income groups, age groups, anything that you can divide the population into, maybe that have different quantities of representation. And the goal here is to make sure that people from every group are identified and included in the sample. So particularly in the United States, there's no problem when you do simple random sampling getting white people in the data, but Indigenous people often are not included. They represent such a small proportion of the population, the chance that they might get randomly selected is somewhat small. And so then it can be hard to represent them in, say, political surveys. You can do a stratified sample to break the groups down by race or geography or something like that. And then you stand a better chance of ensuring that some of that is represented in your data set. So typically they're broken down proportionally. So let's take an easy one. let's say gender, women typically make up 51% of the population in the United States. And so therefore men make up 49%. If your sample that you're trying to draw from, your population that you're drawing from has the sample that you're trying to collect has 100 people in it. Typically you would take a sample of 51 from the group of females that you've separated from the men, and then you would take a sample of 49 from the men. And then those samples within each of the groups are taken by simple random sample. But that ensures that both men and women are represented in the data in the correct proportions for the population. Again, the goal here is to make them representative of the overall population. And so you ensure that there is a correct gender balance. If you simply do simple random sampling on the whole population, you might not get that same gender balance. You might accidentally get a sample which is not as representative. So this ensures that representation. Cluster sampling is also broken up into groups, but typically these are broken up into a large number of small groups as opposed to a small number of large groups. Often this is done for geographic reasons, but it can be done for other reasons. The groups don't need to be the same size, although they can be depending on how the groups are structured. They typically try to keep them at least approximately of similar size. And then what you do is you do a simple random sample on the groups. So you would essentially number the groups, for instance, you would assign them a number, and then you would simple random sample from the groups to pick, let's say, 10 groups that you would sample. Now, in sort of classic cluster sampling, you would then take everybody in the group and add that to your sample. But there are versions of cluster sampling where you then take a simple random sample from within the groups in order to get the sample size that you require. The difference here is that in stratified sampling, you are taking a simple random sample from every group, whereas in cluster sampling, you have many groups, and you sample the groups, and then you take from just those groups that you've selected as your part of your sample, either all of the people in the group or you simple random sample from within those groups. And again, the idea here is in cluster sampling, again, as I said, this is typically done for geographical reasons. Maybe you put all the elementary schools in the country in your population, and then you sample from those. Those all represent groups of teachers, groups of students. And then for the sake of financial reasons, then you only have to go visit a handful of schools and not like one teacher or one student at every school all over the country. All right, so let's go over to Excel now. There is a sampling function in the data analysis tool pack that we can use to construct our samples. And then I will talk a little bit about how we could conceivably do some of this without having the data analysis tool pack around. It is a little harder, but it is doable. All right, so all right, so what I've done is I've found a little bit of data on marital status and amount spent. And so we're going to use the marital status when we just talk about the stratified sampling as our two strata, married and unmarried. But for right now, I just want to worry about the amount spent. The amount spent in my column, I have 1,000 values in my column, and that's going to be my population. And what I want to do is I want to take a sample, and we'll pick a small sample just for the sake of simplicity here. I want to take a sample of 10 observations from this population. All right, so what we're going to do is we're going to go to our data analysis tool pack. And we're going to look for the sampling function. Here we go, sampling. Now, inside the sampling function, we're going to put the input range, and that is just the list of our values that we're going to select from. Now, I'm not going to highlight the header in this example, since I don't actually want to pick amount spent as an observation. If I had selected the header, I could have checked labels. And if I do that, then the amount spent won't, that first line won't be included. What I don't want to do is, since I didn't highlight the header, I don't want to check the box labels, because then that first observation won't actually be available for selection. Now, once I've selected the data that I want to select, then I can choose between periodic, which we would use for the systematic sampling, and the random. And the random is basically just a uniform distribution. They're going to number all of these rows, and then they're just going to pick out the rows as they go. And then the nice thing about this is that it won't just tell me the row number, it actually pick out the values. So I'm going to select a sample of 10. And where do I want to put it? I am going to put it somewhere on my sheet. Try not to put it at the bottom of your spreadsheet. I'm going to put it up here. And if you're picking a lot of them, obviously a new worksheet is actually not a bad idea, but we're just picking 10 as an illustration. And then I'm going to hit OK. And so here's what it did. It picked out 10 values from this list, and it gave me my sample. So we're just going to call this up here, sample 1. Now I'm going to do this again just to show you what happens if you select the labels. Now, the one thing about the data analysis tool pack is that you do actually have to highlight all the individual values. It doesn't really like it if you just highlight like the whole column. It doesn't like that. So you have to go all the way down. Come on. Let's try again. Sometimes my mouse and my computer really don't like each other very much. Something about that didn't work. Let's try that again. And like I said, I'll just do this one more time. Now here I'm going to pick the first row that I had before, and now I'm going to check labels. Random, again, sample size. Let's change it up just so that we can see that there's a difference. Output range, I'm going to put it next to right here. And again, so picked a different sample. I picked 11 values this time. So this is my simple random sample. They're not the same values. All right, now let's look at the systematic sample. And we'll call this sample 3. Now I have 1,000 observations here. And if I want a sample size of 10, then what I want to think about is I want a step size of 100. So N is the sample size. Oh, N is the, big N is the population size. Little n is the sample size. And then K is the step size, which is actually equal to the population divided by the sample size. So in my case, I have 1,000 total values in my sampling frame and my population size, and I want a sample size of 10, in which case I will divide by 10. And if I put an equal sign there, it will go ahead and calculate it for me, which, we should be able to do in our head is 100. So that's the step size that I want to take in my systematic sample. So now let's try this again. I'm going to select from the same column of values, but I'm going to check periodic, and the period is the step size. So I'm going to put in 100. And if you put in the right step size, then it will just cut off when it gets to the end of the list. And I'm going to put this in my sample 3 line. So you don't have to specify the number of samples. If you know what your sample size is supposed to be, then it will get there. Now, if you have an odd sample size, you may have to round up or round down your step size to a whole number, of course. And then you may get that number that you were expecting, or you may get one additional one, depending on where the initial random start of your systematic process began. So hit OK. And again, it went through the list. And let's see what it did. It found, it picked a random value for the first one. So let's see where 2839 is at. I'm not seeing 2839. Anyway, it picks an initial starting value, and then it proceeds to select values, progress successively every 100 steps until it gets to a sample size of 10. All right, so that's the systematic process. Now, how do we adapt this in order to get our stratified sample? Now, to get our stratified sample, we have to first build our strata. And for that, we're going to sort our data by marital status and make those our 2 groups. And so what I'm going to do is I am going to sort my data based on marital status. And I'm going to have unmarried and married. And my amount spent for the married people, I'm going to copy into a new column. Oops, too far. And then I'm going to take the rest of my unmarried people. And put them in the other column. Now let's look at how this broke down. So we have 502 observations in the married category, and therefore out of 1,000, 502 versus 498 in the other category for married and unmarried. So they're approximately equal. If we try to round numbers, we're going to basically get 5 and 5. So they're roughly equivalent. So what we're going to do is we're going to take a simple random sample. We're going to say sample for A and sample for B. If I want a sample size of 10, then I'm going to take, since these are roughly equal to each other, half and half of the data, I'm going to take a sample of 5 from the unmarried column and a sample of 5 from the married column. So if we go back into our data analysis toolpack and we go to sampling, we're going to have to change what we're highlighting. So the unmarried, now you can't do both columns at the same time. If they were representing the same data, that would be no problem. But we don't want them to choose from either column. We want them to choose specifically 5 from the one column and 5 from the other column. So we do one column at a time. And then We'll put those 5 right there. And then we will repeat the process to do 5 from the other column, and that is the K column. And so rather than highlight, I'm just going to type over, oops, K, K, and it stops actually at 503. And I'm just going to verify that that is in fact the case. There's 503, that's my last line. Labels is checked, also 5. I don't want to write over my old ones. I want to put them in the new column. And then I hit OK. And so now these are 5 from the unmarried column and 5 from the married column. And so now that will be my sample of 10 altogether. So collectively for the stratified sample, these samples then go together as part of my single sample of 10. But now I can guarantee that both married and unmarried people have been represented. Now, for cluster sampling, that's a little bit more challenging because what we have to do is we have to break the data up into many small categories. And so just to illustrate the general procedure, I'm going to create a systematic set of categories just so that we can have a number of clusters to choose from. But we want to kind of keep in mind that these clusters can be chosen in any number of ways. They can be chosen by geography. We might have, if this was like purchase data, we could group them by the kind of item that they purchased if there's enough different categories. But for this particular example, I'm just going to impose a sort of arbitrary set of clusters on them. And so what I'm essentially going to do is I'm going to call these clusters, and then I am going to label the first 5 cluster 1. And then I am going to add 1 from the top of the cluster, not the previous line, but from the top of the row. And so when I copy this down, all of these are in cluster 1, all of these are in cluster 2, all of these are in cluster 3, and so forth. And I'll just copy it all the way down to the bottom. And if there's 1,000 people in our sampling frame, then clusters of 5 people each will produce 200 clusters. And so then what we would do is we would choose the cluster. So cluster sampling. So we choose the clusters randomly. Now we can do that from the simple random sample function in the data analysis toolpack. Or alternatively, I said we would talk about how to do this without the data analysis toolpack. The way to do this would be to use the function rand between. This is a uniform distribution of integers, basically. And we would select 1 as our bottom number and 200 as the top number. And then we would select however many clusters we needed to get to the desired sample size. If we only want a sample size of 10, then we only need to choose 2 clusters. If we choose 5 clusters, then we will pick 5. There's 5 in each cluster. That would be a sample size of 25. Now, the rand between function, it is not fixed at this point. Every time I hit calculate, every time I hit enter on anything, these numbers are going to update. And so what I would want to do is copy and paste as values in order to fix a set of outcomes so that every time I recalculate, I don't lose my list. The other thing to kind of keep in mind is that this rand between function might give you the same number twice. And you would have to just take a slightly larger sample, add one additional cluster or something in order to guarantee that you had the correct number of clusters and thus the correct sample size. You can't select from this, you can't select the same cluster twice. Now you can use this rand between function also to do your other calculations. So you could say, again, if the data was, we unsorted the data, we could then select essentially a list of row numbers, use rand between to pick, let's say, from 2 to 1001, and then it would specify the row numbers that I wanted to pull my data from. That can be very useful if I have, let's say, a large collection. I want to pick all the observations from the table and not just one column of values. If I wanted to, again, just pick cluster samples like this, I have a little bit more control over it, but it is a little more tedious to pull the data out of the table, out of the list of the data set. But that is an alternative for choosing these simple random samples. I can simply choose the line numbers using the rand between function. And for the systematic sampling, I would only need to choose the first line in the first group of whatever my step size was, and then just simply add the step size to get the remainder of the selections. Again, it would just give me the row numbers that I would need to choose from and not the actual data. So I would then have to go and retrieve the data. So that it does produce an extra step, but you can do these sampling procedures from Excel, but without the data analysis tool pack. It is just that with the data analysis tool pack, it will just give you the numbers instead of you having to pick the line numbers and then having to go retrieve the values that go with those selections manually.